In this video, we're going to continue with the 2018, and this is problem number 5, free response, and there is no calculator with this problem. So let's take a look at the prompt. Let f be the function defined by f of x equal e to the x cosine x. So we have a product. Letter A, find the average rate of change. So that's going to be pretty easy. Change in y over change in x of f on the interval from 0 to pi. So let's look at letter A. This is a really easy question. And so all we're going to do is come down here and look at the slope. And notice very carefully, I keep pointing this out, that I left my answer in an exact valued form. You do not, in this case, in letter A, you do not need to evaluate cosine of pi or cosine of 0. This is perfectly fine and will get you full credit for the average rate of change. So don't simplify your answer wherever you don't need to. And we'll look at the scoring rubric after we look at my work. In letter B, we're looking for the slope of the tangent line. So in A, we did the average rate of change. And now the slope of the tangent line, of course, is the instant rate of change. So we're going to need to find f prime, the derivative. And we said, if you come back up here, we said that f is a product. So we're going to need the product rule, and we're going to substitute 3 pi over 2 and not simplify. So come down and take a look at my work for part B. In part B, this is my product rule. So I have the first function times the derivative of the second plus the second function times the derivative of the first. And I think I reversed that order, but this is the product rule. So make sure that you did if you don't get the product rule, we're going to have problems. And then I'm substituting 3 pi over 2, 3 pi over 2, 3 pi over 2, 3 pi over 2. I am not going to simplify or clean up that answer at all. I'm going to leave it as an exact value. It gets full credit for part B. So A and B can actually go pretty fast because time is your #1 enemy on the AP test. In letter C, what is the absolute minimum? Over and over and over, we keep seeing EVT, EVT, EVT. So we're looking for the absolute minimum. If you're going to study something, boys and girls, study EVT. So we have our endpoint of 0, we have our endpoint of 2 pi, and we're going to need to get our critical numbers by setting f prime of x, which we found in part B, equal to 0, and solving. This is not hard, but you must persevere. So let's go down and look at part C. So I take my first derivative and I set it equal to 0. I factor out the common factor of, I factored out the negative of e to the x, and that leaves me with sine x minus cosine x. Set each factor equal to 0. Now we know that e to a power can never equal to 0, so we're not going to get any numbers out of that. And then when we have sine of x minus cosine of x equal to 0, think about your circle. Think about what radian angle measure has the same sine and cosine in order to get 0. So that's going to have to be pi over 4. And if you think about your circle, it's going to have to be in quadrant 1 and quadrant 4, where sine and cosine have the same sign. So my two critical numbers are pi over 4 and 5 pi over 4. So you do need to know your trigonometry. Then, to finish the extreme value theorem, I'm going to make a candidates table. So I have my two endpoints of 0 and 2 pi. Sorry about that. And I have my critical numbers. Now, in this case, look carefully at my work. E to the 0 is easy to evaluate, so I evaluated that to be 1. And the cosine of 0 was 1, so I was able to easily generate that y value. Now, I don't know what e to pi over 4 is, but I know it's a positive number. And I know that the cosine of pi over 4, why does that say negative? Less than 0. So that should be a positive number. Here, let me look at the scoring rubric. I'm just wondering why I have that as a negative number. Yeah, that should be a positive. That's my mistake on that. I'm glad I caught that. So let's come back down here. E to the pi over 4 is positive. Cosine of pi over 4 is positive. So this is not less than 0. It's greater than 0, so I have a positive. Okay. We'll come back and figure that out in just a minute. And then 5 pi over 4, cosine of 5 pi over 4 is negative. E to the pi over 4 is positive, so I have a negative, and I'm looking for the absolute, I already forgot, sorry guys, the absolute minimum. So since I have a negative value, this is out because the negative is smaller. And then when I substitute e to the 2 pi into the function, or 2 pi into the function, I get a positive number. So that's going to be out. So the absolute minimum has to occur at 5 pi over 4 using a table of values. And notice again, I never calculated what the value is at pi over 4 or at 2 pi. I was just able to rule them out because I had positives. And again, I'm glad I caught that mistake. And then I think I did a comparison. E to the 5 pi over 4 is less than, I don't really know why I had to do that. I think because I had a mistake in my work up here and said that there was a negative there. I don't think the function itself was negative. Let me go back up here. Nope. Okay. Yeah, so that's good for the absolute minimum. And then let's look at letter D. In letter D, we have a new function g, and g is differentiable. We know that if g is differentiable, that guarantees that g is continuous. I'm writing with a mouse. I'm getting better at that, actually. Okay, so remember that may be important in this problem. The graph of g prime is given below. So what we have here is g prime. Find the value of, we're trying to find a limit, and remember when we do limits, we always start with direct substitution or determine that the limit does not exist, and we're going to justify our answer. So I'm going to substitute pi over 2 into f, which is going to give me, let's come down here. So now we're actually going to have to evaluate that number. Pi over 2 into f gives me e to the pi over 2. Cosine of pi over 2, which is 0, gives me a 0. In the prompt, they tell me, or do they tell me, or do I have to figure this out from the, yeah, the limit as x approaches pi over 2. Come back up to the prompt. They told us that g of pi over 2 is 0, and since g is continuous, then the limit has to equal to the y value. Therefore, the limit as x approaches pi over 2 of g is equal to 0, and that introduces our friend L'Hopital. All right, so I have the setup for L'Hopital. So to find that limit, I'm going to, here's the limit as x approaches pi over 2 of f of x of g of x. Remember, L'Hopital says take the derivative of the numerator, the derivative of the denominator, and resubstitute. F prime, as you recall, we found the derivative of that earlier in, I think it was part B, so I'm substituting pi over 2, pi over 2, pi over 2, pi over 2. G prime of x, I'm going to have to get off of the graph G prime of pi over 2. So when I look at my graph of g prime at pi over 2, I get a derivative, a g prime value, a y value of 2. And so since the denominator is not 0, I don't really care what the numerator is. I do not have to simplify it. I know that I'm not going to run into a repeated situation of L'Hopital. So that's how you work out the problems in number 5. Let's look at the scoring guide. Try to score yourself as best you can. I know it's kind of hard without being in class to do it together. So in letter A, you have to show the setup of the average rate of change. Now, you cannot use F to get credit for your average rate of change. That would not give you the credit, but you can use the E and the sign and get full credit for that average rate of change. In part B, we found the first derivative, so there's 1 point for correctly finding the first derivative and 1 point for evaluating the slope, and you may leave that in an exact valued form. You do not have to simplify anything to get the full credit. In letter C, you get 1 point for showing that you're setting the first derivative equal to 0. It must be visible, must be findable. You get 1 point for identifying the two candidates of pi over 4 and 5 pi over 4. If you don't identify both, you don't get the credit. And then your answer with justification, your table, is your justification, but you do need to declare your final, that's your justification, but you do need to declare your final answer. You can't just leave the table there and expect the reader to figure out what you think the answer is going to be. And then in part D, it was important to declare that G is continuous at x equal to pi over 2. That was really important. And then you had to show that each of your independent limits equals 0. The applying L'Hopital rule is where you're taking the derivative of the numerator and the denominator, writing it as a limit statement, and then your final answer. Notice in the note, you can only get 1 out of 3 points if no limit notation attached to a ratio of derivatives. No limit notation attached to ratio of derivatives. So what they're talking about here is that you needed to show what you're doing, at least this much right here. This was really critical to show what you're doing. So hopefully this was helpful, and then check out problem number 6 for the 2018 video.